You're watching Statistics Made Simple, and I am Savita Balsang. Continuing with small sample tests where N1 and N2 are less than 30, I will explain the procedure for test for equality of means for dependent samples, which is also called as the paired t-test. And I will also find solutions to problems based on the paired t-test. Let x1, y1, x2, y2, so on xn, yn be n pairs of observations. Then their deviations are given by d equal to x minus y. Then their sample mean is d bar equal to summation d divided by n, and sample variance is denoted by sd square, which is equal to summation d minus d bar the whole square divided by n. Here, the null hypothesis is of the form H naught. The two population means are equal, that is mu1 equal to mu2 versus any one of the following alternatives. First one, H1 mu1 is not equal to mu2, which is a two-tailed test. Second is H1 mu1 is greater than mu2, that is a right-tailed alternative. And third is H1 mu1 is less than mu2, which is a left-tailed alternative. H naught, the test statistic is T equal to D bar divided by SD by root of n minus 1, which follows T n minus 1. The conclusions based on a two-tailed alternative are: you have to check if mod T is greater than T alpha by 2 at alpha level of significance for n minus 1 degrees of freedom. We reject H naught, otherwise we accept H naught. For a right-tailed alternative, you have to check if T is greater than T alpha at alpha level of significance for n minus 1 degrees of freedom. Then we reject H naught, otherwise we accept H naught. And third is if T is less than minus T alpha. This conclusion is used for a left-tailed alternative. At alpha level of significance for n minus 1 degrees of freedom, we reject H naught, otherwise we accept H naught. I will now explain how to identify that the given problem is based on the pair t-test. Firstly, the given problem will be based on only n pairs of observations which are dependent on each other, and n should be less than 30. Words like before or after will be used for the samples. N will be given and d bar sd square can be obtained from the given data through calculations. Problem 1. The following table gives the sales of a particular product in 7 shops before and after a special promotional campaign. Can the campaign be judged to be a success? In the first column, we have the shops labeled as A, B, C, D, E, F, G. In the second column, we have before campaign sales as 64, 39, 42, 59, 61, 53, and 60. After campaign, the sales are 69, 40, 41, 66, 67, 56, and 60. The first step is to mark the sales before campaign as X and sales after campaign as Y. Then start with the solution. Write given n equal to 7 and alpha equal to 5%. In this problem, we see that the words sales before campaign and sales after campaign are used, and we have 7 pairs of observations for the 7 shops before the campaign and after the campaign which are given. So this problem is based on the paired t test because n is less than 30. Next, we will write H naught. The two population means are equal, that is mu1 equal to mu2. Now let us learn how to write H1. Observe in the red colored box highlighted on the right side of the slide, we have the mean sales before campaign denoted as mu1 and the mean sales after campaign is denoted as mu2. Now, the question asked is, can the campaign be judged to be a success? Or in other words, we have to check whether the sales after the campaign, that means the mean sales after the campaign has increased as compared to the mean sales before the campaign. So we have to check if mu2 is greater than mu1, which implies mu1 is less than mu2. So our H1 will be mu1 is less than mu2. Then under H0, the test statistic is T equal to D bar divided by SD by root of n minus 1, which follows Tn minus 1, where SD square is equal to summation D minus D bar the whole square divided by n. Let us now consider D bar, which is equal to summation D by n. Now in the table, let us form a column which is D equal to x minus y. So we get 64 minus 69 as minus 5. Similarly, 39 minus 40 is minus 1. Then we get 1, minus 7, minus 6, minus 3 and 0. So we get summation D is equal to minus 21. Substituting in D bar, we get D bar is equal to minus 21 divided by 7. Therefore, D bar is equal to 3. Let us now calculate SD square, which has the formula summation D minus D bar the whole square divided by n, which is equal to summation D minus, in place of D bar replace minus 3 the whole square divided by 7, which simplifies to summation D plus 3 whole square divided by 7. Now let us form a column which is titled as D plus 3 the whole square. So take the first value of D, which is minus 5. Minus 5 you add it to 3, you will get minus 2. Minus 2 square is 4. Similarly, take the next D value, which is minus 1. Minus 1 plus 3 is 2. 2 square is 4. In a similar way, the remaining D plus 3 whole square values are 16, 16, 9, 0 and 9, which gives summation D plus 3 the whole square as 58. Substituting in SD square, we get 58 divided by 7, which is equal to 8.2857, which implies SD is equal to root of 8.2857, or SD is 2.8785. Substituting in t, we get t equal to minus 3 divided by 2.8785 divided by root of 7 minus 1, which is equal to minus 3 divided by 2.8785 by root 6, which is equal to minus 3 divided by 2.8785 divided by 2.4495. On simplification, we get equal to minus 3 divided by 1.1751, or t is equal to minus 2.5529. Now the condition which is used for a left tail test is you have to check if t is less than minus t alpha. If this condition is satisfied, then we reject H0, otherwise we accept H0. So the degrees of freedom is n minus 1, which is equal to 7 minus 1 equal to 6. At 5% level of significance, for 6 degrees of freedom, minus T alpha is equal to minus 1.94. So the conclusion is, since T is equal to minus 2.5529, which is less than minus T alpha equal to minus 1.94 at 5% level of significance for 6 degrees of freedom, we reject H0 and conclude that mu1 is less than mu2. Problem 2. The following are the marks obtained by 5 students before and after attending coaching classes. Test whether marks of students have improved after attending special coaching. In the first column, we have student A, B, C, D, E, and before coaching, the marks are 110, 120, 123, 132, and 125. And after coaching, the marks are 120, 118, 125, 136, and 121. The first step is to mark before coaching marks as X and after coaching marks as Y. Under solution, write given n equal to 5 and alpha is 5%. H naught is the two population means are equal, that is mu1 equal to mu2. Now highlighted in the red box on the right side, before coaching marks, that is the mean marks before coaching is denoted by mu1 and the mean marks after coaching is denoted by mu2. They have asked us to check whether the marks of students have improved after attending special coaching. That means they are asking us to check whether mu2 is greater than mu1, which implies that mu1 is less than mu2. So our h1 will be mu1 is less than mu2. Under h0, the test statistic is t equal to d bar divided by sd by root n minus 1, which follows t n minus 1, where sd square is equal to summation d minus d bar the whole square divided by n. Also, the formula for d bar is summation d divided by n. On the right hand side of the slide, let us form a column, that is d equal to x minus y. Take the first value of x, that is 110, and the first y value, which is 120. So 110 minus 120 is equal to minus 10. Similarly, 120 minus 118 is 2, and the remaining d values are minus 2, minus 4, and 4, which gives summation d equal to minus 10. Substituting in d bar, we get minus 10 divided by 5, or d bar is equal to minus 2. Let us now calculate SD square, which is equal to summation d minus d bar the whole square divided by n, which is equal to summation d minus of minus 2 the whole square divided by 5, which is equal to summation d plus 2 whole square divided by 5. Let us form a column which is d plus 2 the whole square. So take the first value of d, which is minus 10. Minus 10 plus 2 is equal to 8, and 8 square gives us 64. Similarly, take the next value 2. 2 plus 2 is 4 and 4 square is 16. The remaining d plus 2 the whole square values are 0, 4 and 36, which gives summation d plus 2 the whole square as 120. Therefore, we get SD square equal to 120 divided by 5, which is equal to 24, or SD is equal to root 24, which implies SD is equal to 4.8989. Substituting in t, we get t equal to minus 2 divided by 4.8989 divided by root of 5 minus 1, which is equal to minus 2 divided by 4.8989 divided by root 4, which is equal to minus 2 divided by 4.8989 divided by 2, which is equal to minus 2 divided by 2.4495. Therefore, t is equal to minus 0.8165. The condition which is used for a left tail test is you have to check if t is less than minus t alpha. If this condition is satisfied, you reject h naught, otherwise you accept h naught. The degrees of freedom is n minus 1, which is equal to 5 minus 1 equal to 4. So at 5% level of significance for 4 degrees of freedom from the statistical tables for the t-test, we get minus t alpha is equal to minus 2.13. Conclusion: since t is equal to minus 0.8165 is less than minus t alpha, which is equal to minus 2.13, at 5% level of significance for 4 degrees of freedom, we accept h naught and conclude that mu1 is equal to mu2. Problem 3. A certain drug was administered on 6 patients suffering from hypertension and it resulted in the following change of blood pressure, that is 3, -1, 8, 2, 0 and 4. Can it be concluded that the drug will in general be accompanied by decrease in BP? Solution. Write given n is equal to 6 and alpha is 5%. This problem is based on the paired t-test, and the change of blood pressure values are nothing but the d values, that is the difference between the x and y values, where x will stand for the blood pressure before the drug was administered and y would denote the blood pressure after the drug was administered. So here H naught is the two population means are equal, that is mu1 is equal to mu2. Now in the red box which is highlighted at the right of the slide, before administering the drug, the mean blood pressure is denoted by mu1, and after administering the drug, the mean blood pressure is denoted by mu2. Now, the question asked is you to check whether the drug will in general be accompanied by decrease in BP. That means you are asking to check whether mu2 is less than mu1, or in other words, h1 is mu1 is greater than mu2. Under h0, the test statistic is t equal to d bar divided by sd by root n minus 1, which follows t n minus 1, where sd square is equal to summation d minus d bar the whole square divided by n. Table, we will first list down the d values, which is 3, -1, 8, 2, 0 and 4. So summation d is equal to 16. Now write the formula for d bar, which is equal to summation d by n, which is equal to 16 divided by 6, which is 2.6667. We'll just take two places after the decimal after rounding off. So you get d bar is approximately equal to 2.67. Next, let us write the formula for SD square, which is summation d minus d bar the whole square by n, which is equal to summation d minus 2.67 the whole square divided by 6. Now, in the table, the second column you can form as d minus 2.67 the whole square. So, take the first value 3, subtract it from 2.67 and then square the value and we get a 0.1089. Similarly, the remaining d minus 2.67 whole square values are 13.4689, 28.4489, 0.4489, 7.1289 and 1.7689, which gives summation d minus 2.67 the whole square as 51.3334. Therefore, SD square is equal to 51.3334 divided by 6, which is equal to 8.5556, or SD is equal to root of 8.5556. Therefore, SD is equal to 2.9249. Substituting in t, we get t equal to 2.67 divided by 2.9249 divided by root of 6 minus 1, which is equal to 2.67 divided by 2.9249 divided by root 5, which gives us 2.67 divided by 2.9249 divided by 2.2361. On further simplification, we get t equal to 2.0413. Now, this particular problem is based on the right tail test. So, the condition which is used is you have to check if t is greater than t alpha for alpha level of significance at n minus 1 degrees of freedom. If this condition is satisfied, you reject H naught, otherwise you accept H naught. So, degrees of freedom is n minus 1, which is equal to 6 minus 1 equal to 5. At 5% level of significance for 5 degrees of freedom, from the statistical tables for the t distribution, we have t alpha equal to 2.02. Conclusion, since t equal to 2.0413 is greater than t alpha equal to 2.02, At 5% level of significance for 5 degrees of freedom, we reject H naught and conclude that mu1 is greater than mu2. Problem 4. A certain diet introduced to each of the cows resulted in the following change in body weight: 5, 4, 9, minus 3, 0, 1, 7, 4, 5, minus 1. Can we conclude that the diet is effective in increasing the weight of the cow? Use 1% level of significance. Under solution, first write given n is equal to 10 and alpha is 1%. Now, this problem again it falls in the category of the paired t test, and the change in body weights are given for the cows, and these are nothing but the d values. So, x would be the weight of the cows before they were introduced to a new diet, and y would denote the weights of the cows after they were introduced by a new diet, and the difference, that is d equal to x minus y values, is nothing but the change in body weight which is already given to us in the problem. So h naught will be the two population means are equal, that is mu1 is equal to mu2 versus h1, mu1 is less than mu2. Now y is the alternative, a left tailed alternative. Now in the box which is highlighted in red color on the right hand side of the slide, before the diet was introduced, the mean weight of the cows is denoted by mu1, and after the diet was introduced, the mean weight of the cows is mu2. The question asked is you have to check whether the diet is effective in increasing the weight of the cow. So in other words, you have to check if mu2 is greater than mu1, which means that mu1 is less than mu2. So under H naught, the test statistic is T equal to D bar divided by SD by root n minus 1, which follows T n minus 1, where SD square is equal to summation D minus D bar the whole square divided by n. Start with the formula of d bar, which is equal to summation d divided by n. On the right hand side of the slide, we have formed a table where in the first column you have the d values, that is 5, 4, 9, minus 3, 0, 1, 7, 4, 5, minus 1. So you get summation d equal to 31. Substituting in d bar, we get d bar equal to 31 divided by 10. Therefore, d bar is equal to 3.1. The next step is to write the formula for SD square, which is equal to summation d minus d bar the whole square divided by n, which is equal to summation d minus 3.1 the whole square divided by 10. So in the table, the second column formed is d minus 3.1 the whole square. So take the first value 5, subtract it from 3.1, and then the resulting value is squared, which gives 3.61. Similarly, find out the remaining values, that is 0.81, 34.81, 37.21, 9.61, 4.41, 15.21, 0.81, 3.61, 16.81, which gives summation d minus 3.1 the whole square as 126.9. Substituting in SD square, we get SD square is equal to 126.9 divided by 10, which is equal to 12.69, or SD is root of 12.69, that is SD is equal to 3.5623. Hence, we get t equal to 3.1 divided by 3.5623 whole divided by root of 10 minus 1, which is equal to 3.1 divided by 3.5623 divided by root 9, which is equal to 3.1 divided by 3.5623 divided by 3, that is equal to 3.1 divided by 1.1874, or t is equal to 2.1607. The degrees of freedom is n minus 1, which is equal to 10 minus 1, which is equal to 9. The condition which is used for a left tail test is you have to check whether t is less than minus t alpha. If it satisfies this condition, reject h naught, otherwise you accept h naught. So at 1% level of significance for 9 degrees of freedom, minus T alpha is equal to minus 2.82. Conclusion: since T equal to 2.1607 is not less than minus T alpha, which is equal to minus 2.82 at 1% level of significance for 9 degrees of freedom, we accept H naught and conclude that mu1 is equal to mu2. With this video, I come to the end of the testing of hypothesis chapter. The paired t test, which I have explained here along with the problems which are solved, is a very important one, and there is a sure 5 marker in the final exam. So it is important that you identify to which of the tests the problem falls under. So practice the problems thoroughly by understanding the concepts well. Thank you all for watching and look out for my next video where I will introduce the topic replacement theory, which is under operations research.